Hi, this is an introduction to the time value of money concept, the future value of a single sum, meaning the future value of a single amount. First of all, I want to define the factor. We would use a future value factor to help us calculate this, and it is future value factor is 1 plus I raised to the nth power. N is the number of periods, and I represents the interest rate. If you are using tables in your textbook, this is often referred to as Table 1, the future value of a single sum, the future value of a dollar. I want to preface this as saying I teach this concept in several different classes, so I'm going to try to make this presentation non-class specific. Okay, so basic concept here. The formula in determining the future value again is 1 plus I raised to the nth, and I have these listed down here for you to see that n is the number of periods, I is the interest rate for a single period, and sometimes some textbooks refer to I as K. So if you're using this for a business math class or a finance class or an accounting class where K is used, what they're talking about is the interest rate. If you were looking at the table in your textbook, sometimes these tables are at the end, sometimes they are in the appendix of the book, sometimes they're the appendix for the chapter. What you will see is something like this. So the periods are down in the far row, and then all the way across we have, the columns, across we have these columns and of various interest rates. And so what we are looking to do in trying to figure out how much an amount will grow, what an amount will grow to in the future, is we can use these future value factors to help us figure that out. So again, your tables should look something like that. I'm also going to include this information about compound interest. Some of the examples we will look at will just talk about interest compounding annually, and so you can see in this example, if it were compounded annually at 12% interest for 5 years, the interest rate would be 12, the number of periods would be 5. But let's contrast that with semi-annually. If it were 12% for 5 years, but it was compounded semi-annually, then we would half the interest rate to 6% and double the periods from 5 to 10. And you can see what would happen if it were quarterly or monthly or so forth. So I've included this. You can of course come back to this and look at this if you need to. So let's look at, I think the best thing now is to look at an example in a couple of different ways we can solve this. The Brugger Company wants to determine the future value of $50,000 invested for 5 years compounded annually at the rate of 11%. So you can see the little timeline here, right? $50,000 today. What will that grow to in 5 years at 11% interest annually? So there's 3 ways we're going to look to solve this. We're going to solve this using the tables, we're going to solve this doing the math, and we're going to solve this using a financial calculator, because all of these things are available to you. So what table would we use? We would want to use our first table, again, the future value of a single sum. So once I find this first table, I want to figure out what is the factor. Well, I would say I'm going to look for 11%, and I'm going to look for 5 periods. And so the factor I'm going to use is 1.68506. So what this means is the $50,000 in today's money is going to grow to $84,153 because of that present value factor. So that is how we would calculate the future value with, the future value using the table. The next thing I want to show you is how we could calculate the future value doing the math for this. So our future value, this formula is our future value equals the present value times the future value factor. Now that future value factor, that was the very first slide I showed you. So let's put that to work. So in this case, same example, 50,000, 5 years, 11%. So present value is 50,000. I want to multiply it by my factor. So it's 1 plus 0.11, right, the interest rate, raised to the 5th power. So in doing that math, I get 1.68506. I multiply that by the 50,000, and I get the same 84,253. All right, that's the math way of doing it. The third way I want to show you is your financial calculator. Now, everybody's financial calculator is different. And so it's really hard for me to tell you exactly how this works on your financial calculator, that is assuming that you even have a financial calculator. But I want to help you out with some of this kind of stuff. So let's go through this. Usually a financial calculator will have a function to enter n. Again, n is the number of periods. Usually there is a feature for y, interest rate per year. Then there is a feature for present value, future value, and payment. Now in this case we're not using payment, but we will be using payment in a while. So let me show you what we would do here. So in this case I would say n is 5 years. My interest rate per year is 11, or 0.11, and my present value is 50,000. So I would enter those three pieces of information, the 5, the 11%, and the 50,000. And then for my future value I would just press that button to solve, and it would give me 84,253. Okay, so I hope this very brief tutorial would help you now with the future value of a single sum. This is one of several presentations I've put together to help explain these concepts. If you have questions on other ones, please check them out. Thank you.